Well, this evening we're looking at this Agilent 54624A oscilloscope. Been using these at work for over 20 years now. We used to have the previous model before, which is the 54645 and the 54600, which are lovely scopes, and actually the 54645 is one of my favourite scopes. Very easy to use, just a really nice scope to use. This was updated, and we bought this scope in 2003. A number of other models we also bought as well, and this was the later design, and slightly different cathode ray tube, and various things, including a floppy disk option, which obviously at the time was still fairly current, even though I must admit I think USB was sort of like, I seem to remember when we bought this, a number of people said, well, why have we got a floppy disk? Why didn't we buy USB? But we bought floppy, and fair enough, you know, it works. That's fine. And these scopes have been in regular use for 20 years plus at work. But in the last couple of years, this scope, and we've got a couple more at work like this, have developed problems with the soft keys, and these are what we call soft keys. Not because of their tactile feel. Basically, they're software controlled. And they do various different functions, which I'll demonstrate in a moment. And what happens is, and it's usually caused by someone actually doing what they think is a good thing, and is giving the scope a clean. And I think the first time it failed was the time I cleaned one of these scopes, and it was actually a 54645. I gave the thing a squirt down with glass cleaner because it was all sort of dirt. The screen was all dirty. Obviously, because it's a CRT, it attracts dust and stuff like that. So I gave the screen a squirt down. The next day, none of the controls worked. And these are carbon contacts on these buttons, on the underside of this rubber button, and they make contact to a PCB track. And what happens is the liquid gets onto the carbon, and it migrates the carbon and shorts it out to the actual contact itself. So either the switch is stuck on permanently, or it just doesn't work anymore. Now, as I say, repaired this scope a couple of times before, and last time it lasted a couple of years, I suppose. And we bought some very expensive paint-on contact replacement, or carbon replacement, from RS, and it was like a little tiny vial. And I've actually got it in the car. I'll probably show you in the next part of the video, if I've still got it and it's still viable. That you paint back onto these rubber contacts, and it gives you the contact back again. Now, there are other options, a way of doing it. And one of the other options you might have seen in previous videos is to spray on some silver contact paint, which is conductive, and that works quite well, and I've used that on previous HP scopes, and that's no problem at all. Interestingly enough, the Tektronix scopes I use, the 2440 and things like that, actually have the sort of like the membrane keypads with the little button. When you press it, it goes click, and it sort of makes a contact. Even though they feel a bit naff, they seem to be a lot more reliable, and they'll last a couple of 100,000 operations before the actual springiness and the contact goes, and then you've got a broken switch basically. So I'm going to power it up this evening, just show you roughly what's wrong with it, and then we'll run through it. I never particularly like these scopes, and I can't really explain to you why, other than even though the spec of the scope is pretty low, it's 100 megahertz at 200 megasamples per second, it seems to be able to pick out noise and jitter much more than you can on a conventional scope before. The 54645 was 100 megahertz, and I think that was 250 megasamples per second, and yet gave a much cleaner waveform. So the only way I can describe the way these scopes work is they seem to have a higher resolution, and yet their spec dictates that they've actually got a slightly lower resolution than their previous model, or particularly this model. I'll probably be able to demonstrate that in a minute, and I'll show you what I mean. So let's power it up. Now, as I say, these scopes have been used regularly, but and the CRT is really good on this one. I did actually have to turn the gain up on the CRT slightly. The intensity control, the first thing you'll notice, the intensity control doesn't affect the overall intensity of the scope. What it does is it actually affects the intensity of the beam, and that's the first thing that I always found a bit off-putting. You know, if I want to turn the intensity down, I can't adjust the intensity. It's obviously a 4-channel scope. It's got the normal things like the cursors, the quick measurements, and all the things you'd expect from the previous models. But it's got a few other things like fancy triggering options where you can sort of like greater than and less than or equal to. So you can set up different triggers. And we've never ever used these. I don't know how this works, but it's a triggering to sort of like you set in a frequency, and it's got to be less than this frequency before it will trigger, and greater than this frequency. Or if you select this option here, and this on the right hand side, got to be at that frequency before it has to trigger only at that frequency. And it's great in purpose, but in a power supply company we tend to have never used that. So I just run through, let's run a utility test, service, and you see straight away no control over the service button, nothing on the options, floppy, printer one works, which is input output, that one works, that's RS-232 output, and setting baud rates and things like that. Language works, but we've got nothing on service, nothing on options, and nothing on floppy. Now there is another possibility with these scopes, and I'm pretty sure it's just this soft key, but it might have suffered an impact. Now you can see in the top left hand corner here, focus, you see here there's a small hairline fracture on the corner of the bezel. Now I'm not sure these scopes have been out to sites. What happens is when we send equipment out to be tested, we often send a scope with a scope that goes for loan, and it's possible that this scope's been in the back of a car and has been bashed around. I can actually see there's a small crack there. I think that's just a normal stress fracture. These scopes tend to suffer from that a bit. But let me just try and demonstrate this display intensity. So we'll get the free running scope up. So running auto now. Okay, and you can see our scope line here. So a maximum sensitivity on the scope, 1 millivolt per division. And you can see all it does is it actually intensifies the line. It doesn't affect the rest of it, but you also see it's not actually intensity. It's almost like a resolution button. It shows up more information. So let me just plug in a signal to this scope so you can actually see what I'm talking about. It's not exactly easy to demonstrate, and this is a good demonstration here. You see the way this is sort of like not very bright, but this just turning intensity up. It only emphasises the parts that are sort of like have more use. I don't know what the word to describe it is, but you can see this very fine line along here in this noise band. If you can turn that up, intensifies that before everything else. Basically what I'm saying, it doesn't work like a normal intensity controller I'm used to. So let's put the probe compensator, connect that up, and then basically we've got to set our trigger level, and there we go. Right, and let's set our trigger level up. So coupling is on DC, which is fine. Source is 1. Positive going slope. And then you've got to try and work out how to trigger it. Now bear with me, because as I say, I don't use these scopes a lot. Here we go. Edge triggering on channel 1. No problem at all. And you can see our scope waveform looks pretty good. There's a bit of compensation error on the scope. You see it's overshooting and undershooting a little bit, but it comes up nicely. And you see the way the intensity control works. It hasn't actually increased the intensity of this flat line here or flat line here, but it does increase the intensity of the rising and falling edges, which I suppose is quite good in a lot of ways, because if you're triggering on a fast rise and fast fall time, if you can see the top and the bottom, you're not interested in increasing the intensity of that. You want to increase the intensity of the waveform you can't see. And that's good, because otherwise, with the normal scope, I suppose, if you've got this line bright as it is and you can't see that one, if you turn the intensity up, you're going to start burning the screen here and not being able to, and you'll just be able to see the line falling away, but not be able to just burning the screen at the top. So I don't understand how this works. It's not like a normal intensity control where you adjust the grid biasing on the CRT. It's something a bit more complicated than that. We have other options as well to adjust grid intensity, and that's done by this control here, and you can turn the grid intensity right up or turn it right down. I tend to set mine at work very low so you can see it. You've got the persistence control, which basically turns it into a phosphoscope, so if you take the waveform away, it should sort of have some persistence. You see it? We're on infinity persistence at the moment, but you can adjust that if I can remember how to do it. Oh no, that's just infinity persistence. So basically that's like the storage system. Basically the scope remembers the waveform you've got, and it stores it in the background, so you can use that for comparisons and things like that. So apart from the soft controls, this scope's working fine. It's passed calibration last year with no problem at all. That's obviously when the controls were working. So the next step will be is we're going to take the scope apart. We're going to fix it because this scope's clearly got more life in it. I'll just show you through inside of a couple of things, and then need to check the floppy disk controller works, or the floppy drive works, because we rarely use these, but these are useful things to have. It has got some onboard memory as well, very little, but you can store a few settings on board. But it's always nice to have. Certainly when we're working with different projects, basically we put in a floppy disk and call up the project number in the directory, and then say, you know, ripple and noise measurements, startup time, fall time, built-in test equipment timings, things like that, and we just recall those, press return, the scope's set up, and if you do our setting on the power supply, and it's all ready to store. So basically you're not going through and manually checking everything, and manually setting up everything each time. When you've got 10, 15, 20 units to do, you really don't want to be doing that. You just want to be able to recall a setting, do the test, and move on to the next one. Right, let's take this scope apart and have a look inside, and I'll show you where the membrane keypad is. Right, as you can see inside, it's nice and clean. That's because the last time I took it apart, which was the 4th of December 2017, I cleaned it all out with an airline. These scopes do pick up dust because obviously they've got a fan inside, and you can see there's the dust there. It's obviously drawn some dust in. So this is the power supply section, basically a low voltage power supply, and I think there's a couple of fairly high tension rails that feed the multipliers for the CRT and things like that. This side here at the top here is we've just got our cathode ray tube driver, so all that's to do for the screen of the scope, nothing more really. Underneath, this is where all the trickery is done, and you can see here this is a battery that I replaced a couple of years ago, 2 years ago, the end of 2017. This is sort of like the A6 that do all the sort of clever sort of mega zoom stuff. Oh, it's actually got a mega zoom written on it. If you can see that clearly, but it says mega zoom there. So this is all the logic and memory and sort of like the storage area. Got the floppy drive controller here clearly, and we got these cans down the bottom here, which are basically the RF attenuators and things, all very heavily screened and things like that. On the back of the scope, we've got not the normal thing you'd expect on the back of a bit of HP gear or Agilent gear. This is an interface port to address another add-on board that plugs into the back of the scope. So you could have GPIB, you could have printers, you could have probably USB attachments, or even plug it into maybe a network, I'm not sure. We've got a serial port here, which is nice, parallel ports below that, which is just down here. We've got a couple of ports here. One of them is, I think, a trig out, and one's, I'll tell you what they are. They are external trigger and trig out, yes. So various trigger points, which are always useful. This port down here, right at the bottom of the screen, is a 12-volt supply for printer power. So you can plug in your printer, sit it on the top of the scope, and if it requires 12 volts at up to 1 amp, you've got the inbuilt supply from the scope, which is nice. So what we've got to do is we've got to get to the keys that are behind the cathode ray tube, and that's right behind here. We've got to get this part off. So what we've got to do is pop the front panel off, and then pop the switch out, and the switch will be connected to a flexi that's connected to the motherboard. and once we got the front panel off, we can see clearly where that is. And what we'll do is we'll take the switch apart, have a look, see what's actually happened this time. I've got a feeling it's probably the carbon stuff has migrated onto the switch contacts and shorted everything out. So this I'm expecting this to be a fairly straightforward repair, hopefully. And then we've got another half decent working scope. So let me get the front panel off and I'll show you what we're talking about. Okay, it's not visible, but what I did, I just pulled this up as hard as I could without obviously breaking it, and just slid that off, and then you see the front panel's popping off now. So let me get the front panel around. Now hopefully all the controls will lift out because this is the front panel, so we just carefully lift the front panel off. Bit of a wriggle about to get the front panel off. Then we find that we've got this flexi here. Maybe I should have done that first actually. You see this main flexi here, and you can't see it. This flexi here goes down to the bottom of the motherboard and goes to here. This is the flexi here, so we disconnect that, we can put that through. So that's the front panel flexi disconnected, or the front panel disconnected, and that should slide out. So there's your front panel disconnected from the main scope. So put the scope at the back of the bench. We're not interested in that. What we're actually interested in is the soft keys. Now here's the soft key printed circuit board, and as I say, I've repaired this before. Now these are easy enough to get to work on. You don't need any special tools to get them apart. All you need to do to get these apart is you get the circuit board on the one side where my index finger is, lift with my thumb to get it past this catch on the side. Come on, and then just slide it to one side. There you go, it pops out. And there are the contacts that I was talking about, and you can see that they all look clean, and there looks nothing wrong with them. I can see in the light, I don't know if you can see that there's a little bit of sort of like residue left behind from possibly cleaning, but I don't think it's been cleaned since. And there's our contacts underneath the switches. Now the first thing I could try is I just could wipe the contacts with a bit of isopropanol just to see there's a contaminant across them. Pop that contact back in, give these a wipe over, make sure they're clean, and check the switches again. Of course, the other problem that could be is this flexi in this corner here has got a fracture in it, but I hope not, because it was working, it hasn't been apart. So I think the first thing to do is give these little contacts a clean up, slide them back in. We don't need to put the scope back together. We can run it for a short period with the front panel on and the ribbon cable connected up, and do a diagnostic on the front panel, see if that's fixed it, and if it has, brilliant, and if it hasn't, we need to look in a bit further. And now you can see this little catch here, but that's one of the catches that hold the front panel on. You just pull that towards you and you push the front panel away. And there's another one somewhere, I can never remember where it is on the second one, but it's down. Got to go around the scope looking for those catches and pulling them away, and hopefully eventually the front panel will just pop off. Sorry, this is all going to be done by hand, but there's no way of showing you otherwise. So I'm just looking for the other catches. Let's have a look. Is that one there? They're never that straightforward, and it usually comes off at one end, so I'm expecting the other catch to be this side on the bottom of the scope. Clearly got that one to come away. I can't see the other one. So what I'll do is I'll get the front panel off and I'll show you where that catch was. Well, let's give these contacts a little clean up and these pads a little clean up. So we've got a Q-tip or cotton bud or whatever you want to call it, depends where you come from. Of isopropanol, just going to run over these contacts just to remove anything that's contaminating them, because obviously the switch is shorted out. There's a bit of muck on there, but that's probably just carbon from the pads. I'm just going to quickly wipe over these pads. I don't want to go too much, just wipe, 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 and then what I'm going to do is I'm going to put the switch back together, connect it to the front panel, and see if we get any software control again. Software keypad control, should I say. Okay, just booting the scope up again. I'm sorry about the flicker, it's obviously the refresh rate of the camera's beating with the refresh rate of the screen. So obviously the front panel's not on properly. I don't want to put it back together. So can we get any control over anything? So get started. Yep. User. Yep. About scope. Yep. That's working. It's a little bit jumpy. Not brilliant. Formats. So that one works. That works. That one works. That one's not very good, is it? That works. So basically they all work apart from that one's a bit dirty. So I'm going to clean that one more time because it's clearly improved it. So I'm going to take the switch apart again, give it another wipe over. We'll try it one more time. If not, we'll have to retreat it with some sort of dope to make the pad conductive again. Okay, let's try it again. Let's call up some options. Settings. That works. Phosphoride transfer. Yep, that works. That button works. That button works. That button works. That button works. That one's still a little bit dodgy. So they might just clean that one more time. So it's the first, second, third one in. Have a look at this button again just to see what's wrong with that. But basically it does work. It just needs a bit more pressure than the others. So it looks like we've fixed most of them. It's just this last button needs a bit of TLC. Right, screen's back on, or the front panel's back on. Let's give this a go, see if this works, shall we? Right, let's check these soft keys, see if they're actually working properly. So we need to call something up that's got all the soft keys options up, and then we have one there. So let's go through it quickly. Input output, yep, that allows us to adjust RS-232 and things like that. Printer config, yep, button's working. Floppy, yep, that's working okay. Options, screensaver, clock, etc. That's working well. Service, user calibration, etc. Language, it's working fine. So those front panels are now working well. And you can see how nice the scope is, the traces on this, considering this is like a 20-year-old CRT that's been on for probably a total of 10 years in total. And it's quite a bright, sharp display. There's no sign of screen burn, and it's got that lovely sharp image you'd expect from a new CRT. And a lot of people love these scopes, and as I say, I'm not used to using these scopes, and I do use them, but I tend to go for the 54645, which is a more of a conventional storage scope. They've got this has got a lovely display, and a lot of people like the sort of like the key layout on the later Agilent stuff. Obviously, it's got storage for floppy disks, which is a bit dated but still useful. It's got lots of interesting triggering options. You can actually trigger for TV settings as well, which is unusual as a default option on a lot of modern scopes, or more modern scopes. And you saw the other integer options for like greater than, less than, or equal to triggering modes. Never used any of those, doubt if I ever will. So normal triggering options there, positive going, negative going, triggering off which channel, and the option of triggering from an external trigger, which is mounted on the back. Mega zoom, as they all are with the scopes of this age, single shot or continuous run. This is your time-based control. This is your horizontal position. Manual delayed, so you can split the time-based like you can on the sort of like the earlier Tektronix and scopes. I tend not to use those so much. Roll mode, X, Y for Lissa J. You know, it's got all the options. 4-channel scopes, always useful. Every now and then you'll need a scope that's got 4 channels. Very rarely, but every now and then you will. They do suffer from these these knobs are lovely when they're new, rubber knobs, they feel tactile, but they suffer from that sort of like rubber degradation. Just show you, we'll pop this knob off. No, it's not even come off. But even pulling it off, it's left a sort of like a sticky residue on my hand, and it always seems to get all the toe jam stuck in it, which is quite revolting. And I go around and clean them all up with isopropanol. You see that control there is a bit gungy as well. But apart from that, you know, these are highly. A lot of people sort of sought after scope, I suppose, with these. I mean, Dave Jones was reviewing a more modern version of this scope, and he was saying how wonderful it was and thought it was very good. And He obviously knows his stuff. So that's the 54624 scope. Hope that's of interest, and another one to sit under the shelf until the day I die. Thanks for watching. Okay, this is a quick demonstration of it running. Pretty straightforward, putting a 1.64 megahertz signal in from the signal generator. You can see that's the carrier wave there, and we're also modulating with a, what was it, 400 hertz, 1 kilohertz. I can't remember what it is on this. 1 kilohertz, I think. So let's go, set the time base down, and there's your modulation. Now you see the jitter there, and that's because it doesn't know to trigger on the carrier or the modulation, but with a bit of a hold off adjustment, and the hold off adjustment should be able to stabilize that. There we go. And there's your modulation, just the modulation level. Let's bring the whole trigger level down slightly and readjust the hold off. You can see clearly there the adjustments of the modulation and the effects of the modulation. That must be 100% there. Meter's slightly under reading, but that's I must admit that works really well. I don't think I've come across a scope that triggers quite as well on modulation as this scope has. So yeah, and they're nice scopes. You can pick them up on eBay for anywhere between 100 and 150, 200 pounds. Good scope. Just make sure, that's my screensaver, just make sure that the CRT is in good condition, and make sure it's got no obvious signs of screen burn, and you can usually see that by looking at it in a bright light and looking for any signs of any writing on the screen, even though the scope's off, and you can see the screen's pretty good. It's been fairly well looked after, this scope, despite me catching people with the sort of intensity fully turned up, and the scope hasn't been used for sort of hours on end. I just tend to go off and just turn the scopes off. Thought that was hopefully interesting. Thanks for watching, and more to come.